1 in 3 people will have some sort of cancer in their lifetime. There are over 200 types of cancer that can attack different parts of the body.
I was diagnosed with breast cancer back in 2006, so it's kind of gotten more personal for me.
Dr. Kimberly Anderson received her PhD in Chemical Engineering and Bioengineering from Carnegie Mellon University. She is the Gill Eminent Professor at the University of Kentucky and specializes in cancer research.
We're actually working on, with him, developing magnetic nanoparticles that you can actually heat from a remote source. And so there's a treatment for cancer called hypothermia, where you heat these cells up. The problem with hypothermia is it's not really effective on its own, but they found that like radiation and chemotherapy are more effective if you apply hypothermia also. And so the question is, how do you get that hypothermia, the heat, localized to the tumor? So he's actually developing nanoparticles that you can heat from a remote source. We can actually put these in hydrogels and put drugs in there. So you're heating and doing drug release at the same time.
The nanoparticles are inserted into the hydrogel, which will be attached to the cancerous tumor. The remote source that heats these nanoparticles is an alternating current that switches the polarity of the magnets, causing the nanoparticles to move quickly back and forth. This heating makes the tumor more susceptible to drug treatments.
They become more sensitive to things like chemotherapy and radiation, right? Now hypothermia, I mean, other people are looking at just treating tumors with hypothermia, because if you heat to a certain level, they're actually more sensitive to heat than normal tissue. So you heat to like 42 degrees C, and they will die. The question is, do they stay dead? Iron oxide particles is all they are. Okay.
Just travel through your
They travel, right. So different, you're looking at different administrations of those. So one is, yes, can you take these iron oxide nanoparticles and can you coat them with maybe a molecule that will, they're called tumor homing molecules. So you put these on, you inject them into the body, and they will actually go to the tumor and just target the tumor. And then there's actually different molecules where if you have those on the surface, the tumor cells will actually uptake them. Okay. So, and then, other people have looked at, when you go in and maybe you do, let's say somebody has breast cancer and they go in and they remove this, you take these nanoparticles that are maybe incorporated in a hydrogel and you implant them locally, and then you can apply localized hypothermia.
Dr. Anderson is looking for a molecule to coat the nanoparticles in order for them to attach to the tumor or for them to be incorporated in a hydrogel that would attach to a tumor. Hypothetically, this would be administered in a way similar to an IV, where the fluid containing the nanoparticles would travel through the patient's entire body, but would attach to and target the tumor. This process could take 6 or more weeks.
And I guess, with the cancer, a lot of the stuff is, people started out where they thought they were going to cure cancer. And I think finally people have realized that all cancers are different. And so you cannot just cure cancer. You've got to look at specific cancers. And there's never going to be a magic bullet that's going to cure all cancer. I mean, my advisor was very well known for his cancer research in Pittsburgh. That's where we were at Carnegie Mellon. And he would come up with something that we've done in the lab, and the media would get hold of that, and it would end up in the newspaper. Okay, and the way the media presents it is, we've cured cancer. This is and I'm sitting here going, I did that research. I know how basic it is. We're not even close to that yet. Probably when I'm sitting in my grave. I will have to look down and see that someday my research, because that's how long it takes.